Hey guys, meet Patty Hansen. She works on the Hubble Space Telescope project. Today, we're at NASA Goddard Space Flight Center in Greenbelt, Maryland.
Okay, Patty, so far we've learned about algebra, optics, telescopes, and a little about the Hubble Space Telescope. Now, what is NASA Goddard doing to protect the Hubble while it's orbiting around the Earth?
Yeah, and how do engineers like you use algebra in your jobs?
Whoa, those are a lot of questions. Here at Goddard, we're actually the servicing part of the Hubble Space Telescope project. We actually prepare scientific instruments, computers, tape recorders to go up on the shuttle, rendezvous with Hubble, and perform servicing of the telescope. Astronauts go out into the payload bay, get the new equipment out of carriers, and install it on the telescope, and we bring the old hardware home. Now, when we're getting ready for a servicing mission, we have our instruments in our clean room. And in the clean room, we want to make sure we control contamination by having everyone get dressed in what we call bunny suits. And you'll see that everybody in the clean room is dressed head to toe in white. What this does is it controls all the contamination from your clothing, which is lint, your hair. We don't want any dropped hairs on our science instruments, and our skin flakes. Here on Hubble, we're really worried about both particulate and molecular contamination accumulating on the primary and secondary mirrors. Particulate contamination is like a fine layer of dust that scatters the light and doesn't allow it to transmit through the optic and gather into the detector very well. Molecular contamination is a thin film, similar to the condensation that you see on this mirror when I squirt it with the nitrogen cleaner. This doesn't allow the light to be transmitted very well through the optic. Okay, Ben, to get back to your question about how I use algebra in my job, is that I have an end-of-life requirement for the amount of contamination I can accumulate on flight optics. Now, for Hubble, that's the primary and secondary mirrors. End of life is the amount of contamination that we can accumulate from the time it was launched until the time that we no longer expect to take science. And for Hubble, that's 20 years.
So you're saying that in 20 years, you will accumulate some type of contamination on Hubble's mirrors?
That is correct.
Okay.
And what we do is we take periodic measurements and we compare that to our end-of-life requirement.
Okay, let's look at the algebra Patty is talking about. NASA engineers know the total amount of contamination on the Hubble has to be less than 5%, or the telescope won't work the way it should. Before Hubble was launched, the remeasurements for contamination were taken. The first was 0.8%, the second was 0.6%, and the third was 0.1%. The total amount of contamination on the Hubble consists of the amount of contamination measured on Earth plus the amount of contamination that it collects on orbit. If we substitute the values we know into the inequality, we find that the amount of contamination the Hubble can collect on orbit has to be less than 3.5%.
Using algebra, you can see that we have plenty of on-orbit margin left to accumulate contamination on both the primary and secondary optics.
Hey, yo, check it. Did you know that the Hubble Space Telescope is about the same size as this school bus?
This is where all of the data from the Hubble Space Telescope is continuously being collected. Back in 1995, NASA Goddard collected images from the Hubble Deep Field. A few thousand never-before-seen galaxies are visible in this deepest ever view of the universe.